All right, Advanced Math A, here we go. We've got lesson 10.1.3, day 1, comparing data. Okay, so first of all, here we go. We've got, we're going to be the manager at an all-organic orchard, and we know that the farmer's market will only accept fruit that is above average. However, they don't define average. Are they talking about the mean, or are they talking about the median? They don't tell us. So we want to sell as much fruit as possible for premium prices at the farmer's market. Okay, so if we sell at the farmer's market, we'll make more money than if we sold to like a grocery store or something like that. So we want to sell as much product at the farmer's market as possible, and they want us to have it above average size. All right, so our apple crop is represented by this histogram and box plot over here. To get the maximum amount of fruit to the market, should you use the mean or the median for our average? Since they didn't tell us to use mean or median, looks like we get to decide. Well, here's our median right there. And I know that 50% of my data is over here. So that's 50% of my data. So if I want to take half of my stuff, I'm going to use the median. But here I notice that this is a modified box plot, where a modified box plot, in the box plot, it doesn't use outliers. Outliers just appear as dots. So we don't have this really long whisker on this side, because in a modified box plot, you only use the non-outlier numbers to make the box plot, and then you put dots where there's not an outlier. So anyways, here we got this. We've got our median. We don't have numbers, but I do know this, and we talked about this in class, that if we have an outlier, that generally the mean will get pulled towards the outlier. So if the median is here, the mean is going to be, it's not necessarily going to be right here, but it'd be somewhere to the left of our median, because the outlier here is going to pull our data that way for the average, for the mean. Now what that means is if my mean is over here and this is 50% of my data, I can get more than 50% if I use the mean. Because if I use the median, I'm at 50% of my data. And if the mean got pulled this way, I'm getting more than 50%. So I'm going to use the mean, because then I can sell more of my apples. Mean is lower, so I can sell more than half my apples. So I'm going to use the mean. So outliers pull the mean that direction. My lemon crop is represented by the histogram over here and the box plot. Do you suppose the right, why do you suppose the right whisker is missing? So we're missing a right whisker, and that's not an accident. That actually happened. Here's why we're missing that whisker. This value here is Q3, and it's the maximum at the same time. How can we have that value as Q3 and the maximum? Well, remember, from Q3 to the maximum, that's this section here, that's the top 25% of the data. Well, what this means is the top 25% of our data was all the maximum. So our top 25% of our data was repeated over and over and over again. So if our data was like, I'll just do something fast, like 2, 5, 7, 7, 15, 15, 15, 15, 15. Let's say that was my data. This probably shouldn't have been 15, but whatever. All right, so if this was my data, I'll make this one 10, just make myself happy. All right, so this is my data. Here's my median right there. And here's Q3. which is 15, and here's the maximum, which is 15. So the same number is Q3 and maximum. So basically our last 25% of our numbers were the same as the maximum. So that's how that happened. So the top 25% of the numbers were all the same. Next question, which one should I use? Well, again, if I use the median right here, then I can take 50% of my fruits. Now, this one doesn't have an outlier, but what it does have is this slope here we usually call a tail, and this kind of works like an outlier. Here we've got it tailing off over here, and that tail is going to pull our mean over here somewhere. So again, if I use the mean, I can take more than half my lemons. So we would use the mean so that we can take more than half our lemons. All right, part C. Why might the farmers from other orchards feel like you were being deceptive in your choice of average? And we were being deceptive. Well, we weren't breaking any rules, but we were definitely breaking the spirit of the rules. They wanted us to take our top half of our product. They wanted the average. They wanted something over average. Well, we picked the center of our data or average of our data so that it would benefit ourselves. But did the centers that we picked really represent the center of our data? And in both of these situations, I would say no. The center that we chose was not really the center of our data. It's still a center. Mean is a center, but it's not a center that represents our data. So the center we picked or average that we picked was not the center of our data. Did we break any rules? No, we didn't break rules because they didn't tell us which average to use because they were talking about the middle of our data. But we definitely broke the spirit of the rules. We are not bringing our what is more than average, what's above average in our orchard. All right, to best represent numerically the center or the typical value of a large quantity of data, when would you use the mean and when would you use the median? All right, so this is in the methods and meaning section in your textbook. So when I would use the mean, I want data to look symmetrical. Symmetrical means that we could kind of run a line down the middle and it'd look about the same. Now, this isn't perfectly the same, but if I draw a line down the middle, it's about the same on both sides. It's not perfect, but it's close, and we're never going to be perfect. So this would be what's called symmetrical data. Symmetrical. All right, so if our data is symmetrical, then the mean is a good measure of center. However, we had two situations where the mean was not a good measure of center, and this is when we would use our median. We would use our median when we have outliers. Now, specifically, we need outliers on one side of our data. If we have outliers like on this side and then an outlier over here on this side, those two outliers would, balance each other out, and so it'd be more symmetrical. So if we have outliers on one side of our data, we're going to use the median because the outliers affect the mean more than they affect the median. Or when we have data that is called skewed, like our second instance up here, we had skewed data. Skewed data is when we have unbalanced data. I don't know if that's the technical term for it, but that's what I like to call it. So in skewed data, your center is not in the middle like symmetrical data. You definitely have the center or the most showing up on one side or the other, and you get what's called this tail. And your mean is always going to get pulled towards that tail. So if our median was over here, the mean would be somewhere over here because that tail is going to pull your mean that direction. In this case, our tail went this way, so our mean was going to be pulled that way. All right, home sales in Fancyville and Smallville are shown in the tables below. Calculate the mean and calculate the median for these and find out which town has a typical home cost that is the least amount. So we've got 14 data points there, 7 data points here. So remember, with the mean, you would just add all these up and divide by 14. Then you'd add all these up and divide by 7. That would give you the mean. The symbol for mean is X bar. So that's the mean, the average. So the mean for this group here ended up being 506,786 because they're in thousands of dollars here. Our median for this group ended up being 275,000. So there's Fancyville. There's a big difference between the mean and the median. That's interesting. Smallville. X bar, the mean. For this one, ended up being 274,000. And the median ended up being 275,000. Now we want to find out in which town does the typical home cost less? Typical means the middle, right? So what do we use for the middle? Should we, in Fancyville, say that they have $506,000 homes? Or should we say that the typical home is $275,000? Well, we've got two problems in Fancyville. We've got two outliers. This house is $1.1 million and this house is $2.8 million. So those are outliers. Most of Fancyville doesn't cost that much. Those are just the only two fancy houses in Fancyville. Everything else is more reasonable. So we would use the median because we have outliers present here. Whereas this one, all these numbers are roughly close to each other. So we would probably end up using the mean because they're not very far off. There's not any skewing going on. They're about the same. So it looks like, well, pretty much these have the same price. I mean, it's off by $1,000, but when you're spending $275,000, $1,000 isn't going to make that big of a difference. So it looks like the typical home is the same whether you're in Fancyville or Smallville. So the typical home price is about the same. All right, moving on. What's my next page? Did I lose it? Oh, here it is. All right, Trey has an idea. To compare sales in Fancyville to Smallville, let's make a scatter plot with Fancyville on the x-axis and Smallville on the y-axis. And then we can do a line of best fit to see if there's an association between them. Thomas responded, that's a great idea. What's wrong with their plan? Well, their problem with this plan is that, yes, there are technically two variables here. We've got Fancyville and Smallville, but they're comparing different things. When you have a two-variable situation, because remember we said that when in the last lesson, we said that when we are doing a scatter plot, we need to have two variable data. But the variables have to be measuring the same thing. These variables are not measuring the same thing. One is measuring houses in Fancyville. The other's measuring houses in Smallville. They're not measuring the same thing. So this is not two variable data. This is one variable data with two separate data sets. So this is two data sets of one variable data. You might be saying to yourself, Mr. Holcomb, aren't you just saying the same thing? Not necessarily. So if we wanted two variable data from this, here's what two variable data would look like. If I had Fancyville, their homes. If I wanted two variable data, I could look at the cost of a Fancyville home and maybe the square footage of a Fancyville home. Those are two variables of the same thing based on the same piece of information. We're looking at Fancyville homes, and then we could compare their cost to the square footage. That is two variable data. It's not two variable data because I'm looking at Fancyville homes and their cost, and then I'm looking over here at Smallville homes and their costs. They're similar to each other, but they're not the same thing. We're not gathering two pieces of data from the same object. We're taking one piece of data from two separate objects. So this is what two variable data would look like instead. All right, almost there. Paramedics are comparing two different procedures for stopping bleeding from the time when 911 was called to the time the paramedics reported the bleeding was stopped. They stopped it for each procedure. Okay, so they've got all this data. We want to make a combination histogram and modified box plot for both of these. All right, so your first step when you're going to do this is to put them into numerical order. All right, I'm going to go ahead and pause and do all this and then show you my results. But your first step should be to put all of these data points in order. So here I've got procedure C2, so that's not part of our number there, and procedure C7. So here's all of my data points, here's all my data points there. And I'm going to make a box plot and a histogram together on it, and when I come back after I've paused it, we'll see what it looks like. All right, be right back. All right, so you can kind of see what I did here is my first step was I put them all in order. You see that as I was going through, I ticked them off. I double checked to make sure that I had the same numbers here that I had here. So there were 20 numbers up here. So I double checked and made sure that I had 20 numbers here. On this one, I had 15 numbers. I have 15 numbers here. You always want to double check when you're reordering them just in case you miss something. So minimums, that was pretty easy. For this one, there were 20 numbers. So between the 10th and 11th number was my median. In this case, this 6 does count for my lower half. And this is right in between my lower half, between the 5th and 6th numbers. That's Q1. Here's my upper half. I do use this 6 in here. And that's between the 15th and 16th number. So there's my Q3. So I had to find an average here for 4.5 because it was between 4 and 5 for Q1. And Q3 was just 10 because it was between 10 and 10. For the second set of data, my minimum was 6, my maximum was 14. That's pretty easy. There were 15 numbers, so I wanted 7 numbers on this side, 7 numbers on this side, and 1 number in between. So this is my median. Now when I calculate my Q1, I don't use this 10. It doesn't belong in the top 50. It doesn't belong in the bottom 50. So now I've got 7 numbers here, so the 4th number is the middle one, Q1. I've got 7 numbers up here. Q3 would be the 7th number on the top part of it. So my next step is to decide how many bins that I want. So I might do, so this is 20 numbers. Square root of 20 is, it's close to, well, it's almost right in between. No, it's closer to 4. It's closer to 4. It's 4.4-ish or something like that. This one has a total of 15 bins, so that's definitely close to 4. So I'm going to look at my data as I'm doing it, and maybe I'll just do 4 bins. It looks like I might have some outliers on this one. So it looks like I might have some outliers over here. So yeah, I'll probably just do 4 bins and then 4 bins, but only count these numbers when I make my bins for it. All right, so in a second I'll come back and I'll show you the bins that I made and finish this off. All right, so here we go. We finally got it done. So I've got the C2 procedure. That's the one on top with 20 different numbers on there. So you can see that my first bin, I went from 0 to 5. 5 is not included. So in my first bin, I've got 1, 2, 3, 4, 5 numbers. That's the frequency of my first bin. So it goes up to 5. Now my next bin starts at 5 and ends before I get to 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and I don't include 10 in this bin. 10 starts the next bin. So this goes up to 9. That's my biggest bin. So what we see there is that I've got definitely a skewed graph there. I've got most of my stuff on this side and very little over there, or it tails off at least over there. And really you can see the skewing in this tail over here. We can see that 75% of our data, that's this whisker in the box, that's 75% of data. It's clustered together pretty good. But then this top 25% has a really big spread there. So that's what we get from that. For this one, the first time that I did C7, I wanted to make sure to have the same range of numbers, so I went by 5s. But you can see that when I did that, I don't get a lot of bars when I do that, because my numbers, you can see up here in my box and whisker plot, my numbers are very close together. So if I were doing this and just doing it by itself, I probably wouldn't have just chosen to go from 5, 10, 15, because it doesn't give me enough bins to really work with. We didn't have a lot of data, but still, we would prefer a little bit more than this. So I did it a second way, but now we can see these two compared because they're using the same range of numbers for the bin widths. And then over here, we can see, okay, this is what I did if I changed the bins to be 3 for their widths. And now we've got 3 bins that work. And we can definitely see that this is more symmetrical data. It looks pretty close to a mirror image. It's not perfect, but it's pretty darn close. And that's what we're getting when we look at our box and whisker plot. It looks pretty symmetrical up there too. So we would probably use the mean for this one, because it's symmetrical. Whereas this set of data over here probably would be better to use the median as our center because we've got more data over here and less over here. Remember that top 75 was really spread out. So we've got skewed data over here with probably some outliers. The median would be our better measure of center. This one we've got more symmetrical data, and so we would use the mean as our center for this one. All right, that's all I got. Have fun. Bye-bye.